Have you ever watched your sink or bathtub drain and wondered, does the water spiral differently depending on which hemisphere I'm in? Maybe you've heard it's due to some mysterious force of nature called the Coriolis effect. It's one of those ideas that sounds so fascinating and scientific that you can't help but believe it. But is it actually true? Let's dive into the science behind the myth, find out what's fact, and bust some misconceptions along the way. Spoiler alert, the truth might surprise you. The widely circulated claim is that water spirals in opposite directions based on which side of the equator you're on. A common explanation ties this phenomenon to the Coriolis effect, a force caused by Earth's rotation. People say that in the Northern Hemisphere, water drains counterclockwise, while in the Southern Hemisphere, it drains clockwise. It sounds logical, doesn't it? After all, we know the Coriolis effect shapes weather systems like hurricanes and ocean currents. So why wouldn't it affect something as simple as water in a sink or bathtub? Before we answer that, let's step back and understand the science behind the Coriolis effect. After all, the truth often lies in the details. The Coriolis effect is a fascinating force that results from Earth's constant rotation. Picture this. The Earth spins faster at the equator than it does at the poles. When air and water move across large distances, this rotational difference causes them to deflect. It's why massive storms in the Northern Hemisphere spin counterclockwise, while those in the Southern Hemisphere spin clockwise. This effect is crucial for understanding natural phenomena on a massive scale, like hurricanes, trade winds, and ocean currents. But here's an important detail. The Coriolis effect only becomes relevant for large, lengthy movements. Think hundreds or even thousands of kilometers. This is because the effect depends on the scale of the system and the time over which the motion occurs. Hurricanes take hours, even days to develop. So, can the same force that moves colossal storm systems possibly dictate how water drains in your tiny bathroom sink? The short answer is no. The Coriolis effect's influence is too weak to impact small bodies of water like those in sinks, bathtubs, or toilets. These systems are just too small and localized for the Earth's rotational force to make any meaningful difference. While it's true that large storms visibly spiral due to Coriolis, your sink isn't a mini hurricane. The key difference lies in scale. To observe the Coriolis effect, you would need water to be free of any external interference, more on that later, and to take place under controlled, ideal conditions over a very long period. In daily life, the motion of drained water is dominated by entirely different forces you can see and even influence yourself. If the Coriolis effect doesn't control the direction water spirals, then what does? The real culprits are much more mundane. The shape of your drain, how your sink or tub is tilted, and any initial motion in the water have a far greater impact on which way it spins. Let's break it down. *** drain shape. A drain's design can direct the flow of water in a specific direction. Irregularities in the shape can naturally cause water to favor one direction over the other. Tilt of the surface. If your sink or tub isn't perfectly level, even the slightest tilt can guide the water more strongly in one direction. Initial motion. Perhaps the most overlooked factor is how the water was moving before it drained. If you swirl it in the sink, pour it from an angle, or even lightly disturb it, the water will carry that motion as it drains. This starting motion completely overshadows any insignificant effect from Earth's rotation. In short, the direction your water flows down the drain is practically random and determined by these immediate factors, not by the Coriolis effect. Let's test this. Imagine placing two identical sinks in opposite hemispheres, one in New York and one in Sydney. If the Coriolis effect was a dominant force on the scale, water would always spiral counterclockwise in New York and clockwise in Sydney. Simple, right? But experiments don't usually go this way in real life. Variation abounds. Why? Because those practical factors we mentioned, drain design, tilt, and pre-existing motion, all heavily influence the outcome. In fact, real-world demonstrations often show water spiraling unpredictably in either direction, even within the same hemisphere. If you were to manually reset conditions, carefully leveling the sink, ensuring no initial motion, and isolating all other variables, you might be able to replicate a Coriolis-driven effect. But because these experiments require extreme precision, any deviation can send the result spinning in another direction. Literally. Now, this doesn't mean the Coriolis effect isn't fascinating or real. It absolutely is. It's just limited in scope. To appreciate its power, we have to look at phenomena it actually does control. Hurricanes, for instance, are a striking example of the Coriolis effect in action. Massive and sustained over hours or days, these storms are inherently shaped by Earth's rotation. In the Northern Hemisphere, their counterclockwise spirals are majestic and unmistakable. In the South, the clockwise rotation is equally mesmerizing. The scale and time needed for this effect are key to its dominance in these larger phenomena. Animations and visuals can make this so much clearer. Picture streams of air and water bending along the Earth's surface depending on their position. Now zoom in, closer and closer, until you're in your bathroom sink. At this scale, the Coriolis effect fades into insignificance, leaving those practical, mundane forces to take charge. So, if this is science, why does this myth persist? The likely answer lies in a mix of media influence and oversimplification. Popular science shows and books sometimes present the Coriolis effect as an easy explanation for water drain direction without diving into the technical details. It's a convenient, catchy idea, and one that fits snugly into our desire to associate everyday phenomena with larger natural forces. Cultural mythology also reinforces the idea. You may have seen viral videos or proof where people claim to demonstrate this spiral difference along the equator. However, many of these demonstrations are staged, intentionally pre-spinning the water to create their desired result. The myth persists not because it's true, but because it's exciting to imagine global forces at play while washing the dishes or taking a bath. This exploration isn't about taking the fun out of the swirling water myth, it's about uncovering the real story. Science reveals truths through evidence and experimentation, and that's what makes it so exciting. Sometimes, debunking myths leads us to even more fascinating discoveries, like understanding the immense scale at which the Coriolis effect actually matters. It also shows how small, everyday phenomena are shaped by simple, practical factors we might overlook. From the tilt in your sink to the subtle initial motion in the water, physics is alive and well in the most unexpected places. So, does water spiral differently in each hemisphere? The final verdict is resounding. It's a myth. The Coriolis effect doesn't control the direction water drains in small systems like sinks and bathtubs. Instead, the shape of the container, water motion, and external factors reign supreme. But that doesn't make this any less fascinating. Myths like this spark curiosity, pushing us to question what we've been told and dive deeper into the science of the world around us. And isn't that the real beauty of discovery? Try it yourself. Pour water in a sink or tub, spin it different ways, and see what happens. It's a fun and simple experiment, and perhaps the best way to see the truth with your own eyes. If you enjoyed unraveling this myth and discovering the science behind it, don't forget to hit asterisk like asterisk and asterisk subscribe asterisk. There's so much more of the everyday world waiting to be explored. See you in the next video.